instruction here, just sketch the graph here. I would think by this time, especially this class, to say, well, Professor, if you say sketch it, and we've done something like this before, I first would rewrite it. Is that true, guys? Then, probably, take out the negative. Now look at all this that we did last week. And you said, Professor, where are you going? I'm going back to that handout. Wait till you see what happens. And then this cosine is even.
Yeah.
I
So
love
you
that.
get
You
rid of it.
drop the negative sign. And you're left with merely a sketch of that. We've done that. Now, since I do all the work, I should have some students help me out here. All you're going to do is sketch this, and it looks like there's only one transformation if you want to do it through a transformation, or you can bound it. But this one's so easily done through a transformation. Guys, I can take what? The parent cosine graph
Shift it to the.
and shift it to the right.
Higher.
I think they call it a phase shift, horizontal
Yeah.
shift. Pi over 2 to the right.
Mhm.
Okay, guys, let's do that. Let me first remind you what that parent graph looked like. Of course, we all know what it is. And by the way, I've said many times, if you're not enjoying this, you better sit yourself down and say, there's something wrong with me. There's something wrong with me. I just don't say all these relationships. Here we go. Here we go, guys. Parent cosine graph, I think it starts here at 1, does it?
Yeah.
It drops down to 0, drops down to a -1, back to the axis. Back up here, we've done this. And let's say the parent looks something like that for one cycle. Now, Jacob's telling me now, take that parent graph and shift everything, what, pi over 2 to the right?
Correct.
I think this will work out for us. Oh, I hope so. Okay, okay. Guys, therefore, this point now will be where? I'm gonna shift everything over pi over 2 to the what, right? Help me out here. Should I label some more points here? I'm at 2 pi now. Is that true?
Yeah.
Would the next point be maybe after 2 pi? How can I label that? 5 pi over 2, I'm hearing. And then what? 3 pi. Then, I'm hearing 7 pi over 2. And what? 4 pi. Is that true, guys? Now, do we have enough? I just put the numbers there. Shifting everything to the right by pi over 2. Let me do a different color. I thought during the break you guys see this. It's nice. Jacob, help me out here.
Yeah.
So this next cycle is going to start here, I guess. Is that true?
Mhm.
And then what, go down here?
Yeah.
Okay.
And then it
And
would
drop down. Back to the axis.
And then up.
Back up. So you're saying the next cycle, Professor, may look something like this. And I can draw more cycles. Is that true? Now, Sophia, I've done what you had to do. This right here, if we've done it correctly, its graph is the green graph. Is that true? Did we do it correctly?
No.
Okay, what happens here? Did we shift over pi over 2 to the right?
No.
Oh. So it'll be shifting what, pi over 2 to the right? So you're saying that here at the end of that parent graph, this first cycle, this should have been?
There, yeah.
Is that okay? Is it 5 pi over 2?
Yeah.
Are these correct here?
No, you have to shift them all.
Oh, you gotta shift all of them. So you tell me the next one, please tell me? You tell me this 3 pi is wrong?
Yeah, it'd be at the axis.
Okay, it should be what?
It should be at the axis.
On the axis.
Yeah.
So you're saying right here, if this goes like this, then this should have been, I started here. Is this correct here?
No.
See, that's what I gotta get done before I go back and connect it to tonight's lesson.
Everything's got.
Okay, I did this on purpose. Oh, the green marker. Who wants to come up in the green? I do a smooth graph. Make it neat. Matthew, come on up. And relabel what you have to relabel. And let's see what this looks like.
And if we were to shift it,
That's good.
Yeah, they're saying you better erase, they're saying about that green.
we're just gonna plot the points first.
Okay.
So we insert here, come up here, and up here, back up here. So- so- Crazy.
He's gonna change all the graph for me.
Was I supposed to?
Now, leave the parent graph there, leave the
Okay,
red.
then let me just.
The parent graph.
I did not know I was supposed.
That's okay, that's okay. Now, show us what you think the green one is. This guy loves math.
I'm still not making it look right.
No, I think it looks, make it a little darker for me, the
You're doing
green.
great.
Oh, please, I do not need sarcasm right now.
You know, we get sarcasm.
Sarcasm never hurt anyone.
That's-
What's wrong with that?
This is not looking the way I want it to. The point is, it creates the curve.
Okay, now, let's do this. You got it. You got it, you got it. Where's that top for that?
It should be on the back of the motor.
Oh, here it is. Now, I think he's got it for me. Does it end? Now, step to the side there, let's see. Guys, does he now have it, does it look something like that's green? And right here, let's make sure. Matthew, I think you're good. What does the class agree?
Yeah.
Is that representing this?
Yes.
Okay. Now, let's see if that'll work out for me. We accept that. Now, let's make it connect to the lesson I'm doing tonight. This also takes the form of, Nathan, this takes the form of this. There's a graph from last week. Matthew did a beautiful job there. He's got the cycle I want. Now, tonight says, well, also you can think of this as cosine A subtract B. Well, that's cosine A, which is this. Cosine B, which is this. I think the plus next. Sine this. Sine that. Yes or no? Did I use the correct formula? Okay. Ignacio, if I use formula, not sketch here, cosine of pi over 2 is 0. So that means this first term is gone. Sine of pi over 2 is 1. So that merely comes out to be 1 sine x by formula. So I'm saying this is equal to this, and therefore
It's just a
Matthew's
cycle.
green cycle there should really be representing sine. Is that one cycle of the sine graph the green? If you would now connect more cycles to it, I realize it's been shifted over, and he did that perfectly. But would we expect, maybe, would this now come down here, you think?
Yeah.
Yeah.
And would this, where he stopped, I think he stopped here, could I continue to do another cycle here? Guys, is this a piece of the sine graph?
Yes.
And that's exactly what you're showing. So cosine of pi over 2 subtract x, It's the same as sine. Sine x. And we did it by a graph, and then all of a sudden, for the formulas, we connected the formula to it and verified it. It is equal to sine. And that's what he has. He has one cycle of the sine graph there. Now, Jacob, let's get back to where we were. Guys, this is beautiful. To see the graph, all of a sudden confirmed by a formula. Yes?
I do actually have a question.
Go
Is
ahead.
that only in this specific case?
Only. I made sure, during the break, I was just sitting there thinking about it. In my mind, I made sure it worked out.
Would that
I'm
also
good.
work for 3 pi over 2?
Well, it might work out for 3 pi over 2 also. I use pi over 2 because we're talking about complements.
Okay,
Yeah.
thank you for catching.
Now, what's the next one?
Oh, the next one is sine,
Okay, go for it.
inverse sine, 4 over 5, negative 5. Oh, 4 over negative 5.
4, negative 4/5.
Yeah,
Like this?
yeah.
Okay.
Minus inverse tangent,
Oh, my goodness.
3/4.
We may not, hang on. I don't wanna run out of time, I gotta get this finished tonight. I get too excited about this. Deborah, if you look down the final exam, you say, Professor, what on earth is that mess? I know if you take a close look, this all represents an angle. This represents angle B, different angle. And so in essence here, you're looking at sine of A subtract B.
So you just do the same thing as last.
So you gotta use the sine A subtract B formula. If you wanna calculate that mess up there, which is, I think, sine A cosine B. Is it a plus, guys? I think, cosine A sine B. Is that the formula? Thank you, that's what I put on there. Some students are saying, oh, Professor, anything you say, Professor. Anything you say.
so we only switch the signs on a cosine version of that?
Yeah, exactly.
Okay, just.
But you got other formulas. Yeah, I see some students saying, oh, yeah. I put that down on purpose there. Now, Nathan,
Really quick on per beat, for tangent, are we missing, part of the parentheses? Is it inclusive of just tan? Or is it?
right here?
Yeah, like, we're missing,
Oh, there's an extra parenthesis. I think the.
Or is
the
there an
parenthesis
extra
that covers
parenthesis?
everything.
I think it covers everything
Has
here.
to cover the negative, that's why there's so confused.
Yeah, I probably had all this in parentheses. Did I?
okay,
Are you talking about this? Probably.
okay.
Is that what you said?
Yeah, I thought, never mind.
It's just the way it's typed up there. Okay, here we go, guys. Angle A, Austin. Here's that inverse coming up again. I was not gonna work both these, but I'm gonna work in this one. Inverse has a constraint. The angle A must fall between, what was that, negative 5 or 2? Absolutely, we did this earlier also, which means quadrant 1, quadrant 4, we'll go through that. Now, this one's interesting because sine is what, negative?
Negative, yeah.
So I'm down in quadrant 4.
Yeah.
So if you want to sketch, let's do this in red here. Angle A's location is down here. And we may construct a triangle here shortly. When I get to this one, and by the way, guys, before I leave it, make sure we understand, this means sine A is equal to this. Now let's go to B. B, inverse tan. This means tan B is equal to 3/4. I'll put a comma there. Who could recall the constraint placed on inverse tan?
It would be the same.
Negative pi.
Well, not including.
Yeah.
Okay. Quadrant 1, quadrant 4. And guys, I know right now B should be in quadrant 1. We all see B must be in quadrant 1. So if I want to sketch it, I know the green one, B should be here. Now, Sophia, did we want to approach this one through triangles again? I think it's the fastest,
Yes.
without using the identities.
I like that.
Let's do this. Drop a perpendicular up to the x-axis. And what do I know about sine? Sine is a negative 4/5. That means the y is negative 4/5. The hypotenuse is 1. You guys, real quickly, someone please tell me about Pythagorean theorem. What is this missing part?
Wouldn't this be 1 plus 4?
Well, but tell me what the final result is.
Oh, 9.
I think it's 3/5.
Yeah, 3 over 5.
If you use c squared is equal to a squared plus b squared.
Yeah.
Now let's go to B. B is in quadrant 1. What do we know? Its tangent is 3/4. Nathan? Mr. Mathematician. Tell me one way to express on that triangle for angle B that the tan, y over x, is 3/4.
Radian is 1,
Okay, let's make that 1. Hang on. Radius is 1.
and then our y value is going to be 3,
Thank you.
and our x value is going to be 4.
Love it.
And when we.
Hang on.
Oh, sorry.
Now, if I do want this to be a unit circle, and I would do mine just like you said, write down Pythagorean theorem says 3 squared plus 4 squared. I think it's 25.
Yeah.
So I'm looking at 5, take the square root. So this would be a 5, Nathan, I'd be doing the same thing at this point. And Jacob's saying, wait, Professor, we want a unit circle. Easily done now. Just divide everything by 5. Now I have a unit circle, I have a unit circle over here, should be easily done. Now let's find the answer, it's all this. First sine A was a negative 4/5. Cosine B, here's my B sketch, cosine is the x, that's 4/5. Do not, let me put something in wrong here. Cosine A, back to the A sketch, cosine is 3/5. Sine B, the B sketch, I think it's another 3/5. And looks like, guys, I got probably what, is that a negative 16 over 25, subtract 9 over 25, please tell me, is that negative 1? Is it?
That's a nice one.
Is that negative 1?
Yeah.
So all this is surgeon, need your help. Now this last one, I'm going like this. Do an inverse sine of negative 4/5 and see what the calculator shows for the angle.
Negative 53.13.
Okay, negative 63,
53.
53.13. Thank you, hang on a second. And the B, the green one, do inverse tan on 3/4.
Is 36.87.
87 degrees. Now stepping back, okay. Now, hang on. We got this, subtract this, so it's gonna be a negative. Aren't those two adding up close to 90 degrees?
Yeah, pretty close.
Yeah,
Oh, is that
Exact,
yeah.
yeah. Exact.
Negative 9.
right? Not 90 degrees with the number she gave me?
Yeah, but
Okay.
it would.
So I got this, subtract that, a negative, and sine of a negative 90. I could pull the negative sign out front since sine is odd. Does it actually come out to be negative sine of 90?
Yeah,
Which is negative 1.
Yeah,
Is that true?
that's a pretty cool one.
Ooh, that was a nice one. I'll create these for you. Jeez. Now, what else do we have here?
Next we have tangent.
Wait. Now, let's see how much involvement this one is, because I
Oh.
may slow down a little bit and jump down to the end. Okay.
I think it will be simple. Tangent of 7 pi over 12.
Oh, that's all.
Yeah.
Oh, I know why I did this. I know why I did this. Nathan, this class is blessed. We're blessed. good for instruction. Right? Should work out for us. Jeez. Now, you said, Professor, I've never seen a 7, 5, or 12 on that unit circle, and you never will. So they want 10. You say, all you give me tonight, Professor, are the basics, sine and cosine. Sine A plus B, sine A minus B, cosine A plus B, cosine A minus B. Even if I find two angles that produce something for 7, 5, or 12 from the unit circle, you have not mentioned tangent, Professor. Have I given you tonight a tan A plus B in case I need it? No. Did I give you a formula for tan A minus B?
No.
No. What am I gonna do?
Tangent equals sine over cosine.
I've got to use sine over cosine. Now, you say, wait. Professor, geez. Did so much tonight. By the time you get that Math 7 class, you'll see where it pays off. If it doesn't pay off, don't come back to me. Mm-mm. Sorry, when you go to that Math 7 class, don't tell them you had Ramsey. Unless you get the A. If you get the A, say, oh, what'd you ask for Math 2, Ramsey? Get something else. Don't say anything. Now, look at this. I doubt if I finish this up. You just use first a formula for sine of 7 pi over 12. Can anyone give me a combination from the unit circle first? Jacob, maybe I can use it as an A plus B or an A minus B. What do you have
I
in
was
mind?
gonna say sine of pi over 3, plus pi over 4.
Hang on. If I use a common denominator of 12 and check it out, that's exactly right.
So we could also.
Now, no, hang on. Then you have to run to the sine A plus B formula, which is given, and use it. I'm not going to complete this all the way. Down here, I'm assuming, Jacob, you use the same
Indeed.
pi over 3 plus pi over 4, and then use the cosine A plus B formula that's given to us. Is that true?
Mhm.
Now, this will be a mess. So you got one formula on the top in the numerator, another formula on the bottom in the denominator, and then you got simplified. Which may take a little effort there to simplify it. Now, would you like to have a direct formula
Yeah.
for a tan? A tan of, we're using here probably A plus B. Tan of A plus B, this is tan of A plus B. Is that true? There is one given in the textbook. Any student, and every time I throw this out, students are looking at the textbook. Sometimes instructors think they're not, or online. There is a direct formula for tan A plus B. If you should use it correctly, I'll give you full credit, but we'll end up with the same answer. If you say, no, Professor, I don't like formulas, so I've had enough, so just stick with this, and go for it. And you'll get the same answer. But there is a direct formula if you need it. I work with it, it's in the textbook. Jacob, what's that question?
Nothing.
Okay, so I'm finished with this one. You guys can just make the replacement, right?
Mhm.
Just make the replacements cleaned up. Okay, Jacob, what's next?
Next we have establish.
Oh, hang on.
Oh, we already
Oh, we did this earlier.
Oh, we did, okay.
The graph.
Oh, perfect.
Whoa, what happened?
We just did it earlier, so,
Oh, we did this one earlier?
Yeah.
Oh, great, it was on there.
so we can flip to the back.
No,
No,
we didn't do a mathematical preview, which is looking at the graphs and all the answers, and we came up with a conclusion.
Wait, Austin, so you're telling me visually you were doing all these, a lot of these tonight? By graphing?
No, just for this problem that we, it's the cosine pi over 2 minus theta equals sine theta.
And I think we did it earlier, we confirmed it was by graphing, it was.
Yeah,
Yeah.
but did you want
That's
us?
what Matthew did for us, yes. Came out through science.
Is there like a mathematical way to prove this?
Oh, I think we did.
Yeah, we did.
Hang on, Austin.
Isn't that with
No,
sine?
go ahead, right here, did we do it by formula?
To the right of that.
And to the right of this, well, this is what, cosine A minus B? Here we go, got you. You're saying, Professor, could I continue further and now apply the cosine A minus B formula And I think, guys, did I do
Yeah,
that?
we did
Oh,
that.
right here it
Yeah,
is.
yeah.
Yeah. So we did confirm it by formula, then he did it by draw that one cycle of the sine graph. Guys, establish, now tell me what on earth do they want me to establish?
Oh,
It was just
It
that,
was
just that.
It was that.
Oh, that was it?
Yeah.
So now we're on 6.6.
There you go.
Double angle and half angle formula.
Now, I'm looking at my time here. Oh, if I had not prepared this, we're concluding chapter 6. We're concluding chapter 6, if I get through those last two parts there. First was what, double angle formulas?
Double angle and half angle formula.
Hang on. I'll say a little bit about this. By the way, anyone taking a winter class during winter session? Anyone taking a winter class? Not math, I'm not saying math, just any class. Anyone taking a winter class? Yeah, Laura, stop by. I'll be here at 12:30. With my master, yeah, stop by. I'm serious. Oh, you're gonna be doing it online? Anyone on campus? Yeah, stop by and see me. I'll introduce you to the class, the winter class.
What time?
It starts at 12:30. My class starts at 12:30 and goes to around 3:30. Yeah, then they have a little session in 63 like you guys have. Okay, double angle. Jacob, before I jot down the first one, I think I may have just given you the formula what it was.
Yes, you did.
That says now you've got to come up with, we're about finished with, we're almost finished with formulas. This is sine of double theta. And then pretty soon, if I get time tonight, which I may not, I usually ask my students to derive a formula on their own for sine of triple theta. But we're going to do double theta. Laura, I know the formula's listed for you, but I'm going to show you how to, or where it came from. Guys, I could rewrite sine double theta easily as this. Which now makes it take the form of sine A plus B. And that's one of the formulas we solved tonight. So since you have it, I'll just quickly apply it. Sine A cosine B plus, make sure I got this correct here, cosine A sine B. Is that correct? With the sine A plus B, the green one there, formula. Yes? Now, of course, I was using theta. So this is sine theta, cosine theta, plus cosine theta, sine theta. Now, any good student looking at those will say, Professor, these two terms are alike. They're like terms. Combine them, you get two of them. And that's your formula. That's where it came from. Actually, that's where it came from. Ignacio, I don't have this on the handout. I'm not going to do it fully. Tell the class, Mr. Mathematician. Suppose all of a sudden you see an extra credit maybe. And I say now derive a formula for sine triple theta. Oh yeah, I'm going to show you how to use this formula here shortly. Tell the class what you might have in mind. Say, show the work, establish for me, derive for me.
Sine theta plus, of theta plus.
Beautiful. Beautiful. That's 3 theta. Does that also take the form of sine A plus B?
Yeah.
Now I can apply that to sine A plus B formula and make some replacements, and he has it, and you can get an answer. I'm not going to give you the answer. Now this one I did finish up. This is a sine double theta formula derived for you. This one, you have to finish it up with his help. Finish it up, and you come up with another formula for sine triple theta. Easily done though. Now though, with that said, trying to close all these formulas down, guys. I know it's wearing you out here. Austin, if I should ask you to find sine of pi over two, you say, oh, Professor, for goodness sakes, I know that's one. And somehow I have forgotten. That was one. I was having a bad day and I just forgot it was one. Could I express this as sine, thank you, double, you get that double in there, double pi over 4. Are we saying the same thing? Is that true? Now, since I have rewrote pi over 2 as this, I can now apply this formula. And the formula is down here. Nathan,
In
formula
this
says,
case.
since I have this is 2 sine of theta cosine theta. Is that true? So what am I supposed to do? What's theta? Thank you, it's right here. Is that the theta we're talking about?
Yeah.
So it's pi over 4, so this is 2 sine pi over 4 cosine pi over 4, and this is 2. I think this is radical 2 over 2. We've seen so much. This one's radical 2 over 2. And guys, if we clean that up, simplify it, I think all that is 1. Is this all simplified this? I hope it is. I'm looking at myself, is it? Yeah. And should that be sine of pi over 2? Is that what the unit circle says, sine, the y coordinate of pi over 2 is? Of course, and you just confirmed it by a formula. Okay, a double angle formula. Okay. Now, Jacob, we're about to finish this. Did I now show you the cosine?
Yes,
Okay, hang on.
much more complicated.
A little bit more, but I'm gonna get it out of the way tonight. Cosine double theta. Someone give me a start. How would you start to derive and find it yourself? Find the formula, Jacob.
Well, I would rewrite it as cosine theta plus theta.
Thank you.
Which takes the form of cosine A plus B.
There you go. Now we'll just jump right into that formula. We saw the formula earlier tonight.
Cosine A.
Okay, here we go. He says it's cosine A.
And then
Look here.
Cosine B.
B
Cosine
minus
A. It is.
Sine A.
cosine A.
Was it a minus sign? I think.
Yeah, because you switch with cosine.
There you go. You got that. Woo! Now we apply that green formula to what he has here. Applying the cosine theta plus theta, A plus B, guys, we end up with cosine theta. Cosine theta. Subtract sine theta. Sine theta. That's right, did I put it in there correctly? Looks like, if I'm careful, the first term says cosine squared theta. Second term, sine squared theta. I thought that was 1.
Yeah.
Isn't that supposed to be equal to 1? Look at those heads shaking, you know it's not. Shame on you. I will see you during winter class. I saw 3 heads shake. I saw 3 heads shake.
Isn't it?
Mhm.
Squared
I
theta.
thought, yeah, that's not 1. 1 is what?
Plus.
Cosine squared plus sine squared. Or sine squared plus cosine squared. That's not 1. So I gotta stop. Tell me, Jacob.
Yeah.
Did I have for one of the formulas for this
Mhm.
to be that?
That is one of the formulas.
Okay, wait now, we're gonna write other variations, but I have that. Now, I don't remember which order I placed these. Nathan, I could, if I'm clever, I may need this, I could say, well, Professor, I accept that, I see what you did, but couldn't I replace this if I wish cosine squared with sine squared plus cosine squared is equal to 1? Can I replace that with this? 1 subtract sine squared.
Yeah.
And of course, you still got this. And if I put it all together, I think one subtract combined like terms, you have another version of this. And who knows, that second version may be a little bit better for you in certain situations. Can anyone tell me what I might do, back up here, to come up with a third version?
You could replace sine by 1 minus. cosine
Replace sine squared.
theta.
With what, 1 minus
Cosine
cosine squared? Let me do it right here, go back to the original. And he says, Professor, leave the cosine squared out front. But replace sine squared with 1 subtract cosine squared, which it is. I think, guys, when you clean that up, I know I'm at the bottom of the board down here. You're going to end up with 2 cosine squared theta minus 1. Yes or no?
Mm-hmm.
Now, which of those 3 you want to use depends on the situation. But now you have 3 formulas guaranteed to work for cosine double theta. Jacob, I gotta watch my time here. Oh, that's beautiful. We're going to close chapter 6 down. Did I give you a tan double theta? No. Did I give you a secant double theta? No, nor am I. Are there formulas for those? Yes. Laura, if I ask you for secant double theta, you say, wait, Professor, you didn't do a secant double theta. You don't have another handout. Assuming, Professor, you're not going to derive one. What could you do, though, to end up with secant double theta without going through and find another formula? 1 over cosine double theta. Take a reciprocal. And if I ask you to find tan, and I have not given you a formula, even though there's a formula out there somewhere, you can put what, sine over cosine? And have a tan double theta formula. Now, I'm checking my time. Jacob, first tell me, how much more do we have to do?
We have 1, 2, 3, 4, 5, 6 more probably. But 3 of them are like interlaced.
Okay, ask that question. Let's see.
Okay, the first one is given tan of theta.
Hang on, I'm all off the board here. Given?
Tan of theta equals 4 over 3,
Okay.
and theta lies between pi and 3 pi over 2.
Okay. Like this, I guess.
Find the exact value of the given expression.
Hang on. And what's the first one?
The first one is sine double theta.
Beautiful. Beautiful. Guys, we did it. Proud of you. We're gonna get this done. I may not be able to finish all those exercises remaining, but we're going to get most of it done. Any ideas, guys? He's asking me to find sine. You'll say, Professor, all you've given me right now is a formula. Here's the formula for sine double theta. So if I want to find that answer, I know before I take suggestions here, you've got to use this. Got to use that. They gave me tan. And they'll tell me which quadrant. I caught between pi and 3 pi over 2. Thank you, that's quadrant 3. So I know where I'm located. Matthew, go for
So
it.
the first thing you can do is just derive our sine and cosine from tangents.
Oh, you mean sine or cosine?
Yeah.
Okay, be careful. See what, you gotta be careful with when you say, I agree 100% tan is sine over cosine. If I do it right now though, you might be tempted to say, well, Professor, sine is 4 and cosine is 3. Hang on, but is that sine or cosine? Now, Sophia,
Yeah.
what's that?
Do the identity with the secant.
Okay, she wants me to use an identity like what? Probably 1 plus tan squared equals secant squared. Matthew, I've done this myself. You say sine over cosine, Professor, sine is 4 and cosine is 3.
No.
That's what's wrong with me saying sine is 4. How high up does sine go?
It goes from
1.
You would have to do the thing where you
You're
define.
not gonna stretch it.
You can.
We're talking about the basic sine. his sine amplitude 1. Is that as far as the graph goes? I can't get to 4 unless I put a 4 out front. Is that true? So I can't do that. So I think the best bet is, Sophia, tell the class again. 1 plus 10 squared. There, thank you. Equals this. And she says, Professor, they gave you tangents, so you can put in what, 4/3? And right there says 1 plus 4/3 squared equals this. You guys help me out there. It's 1 plus what, 16 over 9? Help me. What, 25 over 9? Equals this. Take a square root. Right now it looks like it might be that. I know I gotta use this. Is that true? So I'd better change this to a cosine right quickly, since I need a cosine for that green. Just take the reciprocal, and it turns into cosine. I'm hoping I can take that back to where I need it. Hang on. I know what you guys, I know you guys by now. I'm gonna miss you guys. Which quadrant though am I in? Quadrant 3, and we're doing a cosine.
So it has to be negative.
Is cosine out in quadrant 3 negative?
Yes.
So I've got to prefix this with that thought, and that goes up there. I'll do that later. Now I need to come up with sine. Yes?
Could you in theory do the whole thing where you drop a vertical?
Absolutely. We may approach that before I leave.
Okay,
You want to find sine now by using what? Sine squared plus cosine squared is equal to 1.
Just use a tangent.
Or just use 10 is equal to, I got you.
yeah.
Now, Matthew, since we have this, I could say tangent, I'm hearing students say I could try this on the side. Tan theta is equal to sine over cosine, which we all know. But I could not use it originally. But now I know what cosine is, right? Cosine is negative 3/5. Is that true? Now what would sine it to be, to turn this into 4/3?
Negative.
Another negative? Yes or no?
Negative 4/5.
Negative 4/5?
Yeah.
Now will that turn into a positive 4/3 like they said tan should be? Okay? Now those values make sense. Guys, if that's true, Nathan, let me go ahead and fill in sine theta then. We think it's negative 4/5. So put it right here. Of course, let's bring that up here. 2. And guys, this times this times this will be a positive. It's like 24 over 25. I'm on top of the board here, see if you guys agree. Is it positive 24 over 25?
Yeah.
Is it? Sophia, good suggestion to use this. Okay. Jacob, what's next? Where are we about?
The next one is cosine or double theta.
Okay, now, guys, the board's full. And I think the instructor who sat in the back maybe 2 weeks ago was asking me, my goodness, your students are enthusiastic, and remember that at the end of class we got up and worked out a problem or something, had a handout or something, you guys were working in groups or together, you remember that? He was saying how exciting.